Welcome to all of you in Sankalp Education Pratham classes. I am Sachin Patel, delivered lecture series on derivative. Right now we are going with the derivatives of implicit function, and we have to taking the another two proofs are here. That means first of all we have to get the y is equal to inside the square root cos x plus inside the square root cos x plus inside the square root cos x plus and so on to infinite times is here. That means inside the square root cos x, inside the square root cos x plus and so on. Then we want to show that dy by dx is equal to sin x divided by 1 minus 2y is here. First of all we have to get we have to think about the given is here. We have y is equal to square root of cos x plus square root of cos x plus square root of cos x plus and so on up to plus so on up to infinite time is here. So on up to infinite time is here. Right now we have to squaring on both sides. Squaring on both side. Squaring on both side. That means we have to take the square of this one and also square of this one. Then you will get the consideration of y square is equal to 1 square root is vanished here, and you will get the consideration of cos x plus inside the square root cos x plus inside the square root cos x plus inside the square root cos x plus dot infinite time. That means there will be no any matter when 1 cos x is taken outside, there will be infinite time of cos x plus square root of cos x plus square root of. That means here when 1 cos x is taken outside by squaring, there will be no any change in the infinite times of that one. That means this term, this particular term, this term is once again is nothing but a y, and therefore we have to put y is here. You will get the y square is equal to cos x plus y is here. Cos x plus y is here. That means we have to put the once again y for that one. Where cos x is taken outside, there will be no any change in the infinite time, because it is an infinite number of times you have to carried out that particular consideration. Now this y square is equal to cos x plus y is here, and now taking the derivative with respect to x is here, you will get the consideration of y square having the derivative is a 2y into dy by dx is equal to cos x having derivative minus sin x, plus y derivative of y is nothing but a dy by dx is here, and this dy by dx is transferred to this side. You will get the consideration of 2y. We want to find out the consideration of 2y into dy by dx is equal to 2y into dy by dx minus dy by dx is equal to minus sin x is here. Now we have to taking the common dy by dx from that one. You will get the dy by dx inside the bracket 2y minus 1 is equal to minus sin x is here. Now this 2y minus 1 is multiply here, then it is divided here, then you will get the dy by dx is equal to minus sin x divided by 2y minus 1. But we think about the our proof is nothing but a dy by dx is equal to sin x divided by 1 minus 2y. Then this minus sign is in a numerator. You can also take inside the denominator, because we know that the minus a divided by b is equal to a divided by minus b. It is equal to minus a divided by b also, and therefore you can going with one consideration of this minus sign is taken inside the denominator. You will get the consideration of sin x divided by minus inside the bracket 2y minus 1 is here, and this is your dy by dx. this minus sign is taken inside the bracket, you will get the consideration of sin x divided by this term becomes a minus and this term becomes a plus, that means minus 2 plus 1, and therefore you will get the sin x divided by 1 minus 2y, and this is your proof related to that one. This is a proof of that one. That means you can conscientiously think about the what are the showing is here and what are the required derivative or required result from that one. And for this purpose, when we want to change something by using a particular rules, and you have to change something by using some substitutions, at that time you will get the final result related to your derivative. Similarly, you can find out the derivative related to that one. First of all, we have to get the consideration of we have e raised to y is equal to y raised to x. No doubt, e raised to y is a normal function, but y raised to x is nothing but one function is in index of another function, and therefore first of all we have to take the log on both sides. Taking log on both sides, log on both sides, you will get the consideration of log e raised to y is equal to log y raised to x is here. And therefore this y is in index, it is taken as a multiplied, therefore y into log e is equal to x into log y is here, but we know that log e having the value 1, and therefore y into 1 is equal to x into log y is here, and therefore y is equal to x into log y. Now taking the derivative on both sides with respect to x, taking derivative on both side with respect to x is here, you will get the derivative of y is nothing but a dy by dx is equal to derivative of this one is nothing but a multiplication of two functions. This function x is one function and log y is another function, and therefore x into d dx of log y is here is plus log y into d dx of x is here, and according to that one you have to get the consideration of x into derivative of log y is nothing but 1 divided by y into dy by dx plus log y into 1 is here, and this is your dy by dx. Now we have to get the consideration of this one is nothing but a this term is transferred here, you will get the consideration of dy by dx minus x divided by y into dy by dx is equal to log y is here, and now dy by dx taken common from that one, you will get the consideration of dy by dx. Right now we have to taking it here, dy by dx inside the bracket 1 minus x divided by y is equal to log y is here, log y. Now we have to get the consideration dy by dx inside the bracket y minus x divided by y is here, and it is equal to log y, and first of all we have to think a consideration of that one is nothing but a what is the result you want here. First of all we have to transfer this term here, then you will get the dy by dx is equal to log y into y divided by y minus x, because this is a divided multiplied here and this is a multiplied divided here, but this is not a final result because our final result is this one. That means there will be some substitution you want to put, because one log y is present but no another log y and log y minus 1 is there, and for this purpose here we think about this consideration y is equal to x into log y. We have to put this value here, you will get the consideration of log y inside the bracket x into log y divided by y is equal to x into log y, put it here, and also put it here. You will get the x into log y minus x into log y minus x. Then log y inside the bracket x into log y divided by x is taken common, and inside the bracket log y minus 1 is here, and x is x cancel to each other. You will get the log y inside the bracket log y divided by log y minus 1 is here, and multiplying this log y, you will get the log y square divided by log y minus 1 is here, and this is a dy by dx, and this is your final result you want to show here. And according to that consideration, you can find out the derivatives, and then if any requirement of putting inside this one, you can use the different things which are conversions inside the our function, and according to that substitution, you will get the final result of that one. If you like that video, please subscribe my channel and press on bell icon to get the next notification related to that derivative series. Thank you.